Hi everyone, welcome to the channel. My name is Aftab Ahmed and today we are going to study the first chapter of class ninth chemistry, which is matter in our surroundings. So today we are going to learn few of the concepts from this chapter in lot of detail. I'll try to keep my language as simple as possible so that you can understand the concepts relating it with real life examples. Along with that, we will be doing some questions which will help you understand how to apply these kind of concepts and what kind of questions can come in the examination from these topics. Okay, so without any further delay, let's get started. So the first thing which we will do, or I want you to do, is observe. Like, what I want you to observe is look around yourself. What do you see? We see trees, we see our house, we see the clothes, we see the food, we see the water, right? We see the devices, we see the notebook, we see the pen. So why am I asking you to do this? And what is common in all of these things? Well, if we pay a little attention, we will get to know that all of these things have some amount of mass and they occupy some amount of space. That means they have certain amount of volume in them. Yes, isn't it? Right? Let's say the book which is placed in front of you right now, right? That book, when you lift it up, you will feel that some amount of mass the book is having. The book is occupying some amount of space. The book is having some amount of volume. So that is what we call to be as matter. So anything which has mass and occupies space, that means it has some amount of volume, is called as matter. As simple as that. Okay, so we'll write few examples: the book, the food, the water, the air, right, etc. So anything which has mass, occupies space, is called as matter. Okay, so let's move ahead and talk about the physical nature of matter. So we'll talk about these things one by one. First is matter is made up of particles. Now, how will we prove this thing? That matter is made up of particles. Like, we have not seen, not everybody seen them under a microscope, or we will not get to know just like that. We need to have some example, some proof, some experiment with the help of which we can say that matter is made up of particles, right? Okay, let's do some example. I have a beaker, okay, and I fill water inside it. So I have filled some amount of water inside this beaker. And what I will do is I will add some amount of salt in this water. Okay. Now I'm sure you guys know that when we add water and salt together and give it a stir, what will happen? The salt gets dissolved and it disappears from the naked eye. So where did the salt went? When we added, it was there. When we give it a stir, it dissolved and it disappeared. So if I zoom this particular image after added salt into water, we can see clearly that if I draw the molecules of water with blue color circles for easy visualization, I can see that some of the salt particles have occupied the spaces between the water molecules. Okay. So the particles of salt has occupied the space between the particles of water. Okay. Also, I'll give you one more example to understand this particular physical nature of matter. Let's say we have a house. Okay. We have a house. What is house made up of? Well, house is nothing but a combination of bricks put together to construct a wall and the roof and the columns and all those things, right? So house is made up of bricks. What is bricks made up of? Well, bricks is nothing but say sand and clay put together, dried it up and got a perfect shape, right? So sand. Okay. Now, what is the nature of a sand? I'm sure you say that sand is present in the form of particles. So like this, we can say that sand have made bricks, bricks have made houses. Sand is also having some amount of mass. It is having some amount of volume. So is the bricks and so is the house. Correct? So particles of matter, when you consider house to be a matter or brick to be a matter, even if you consider sand to be a matter, sand is also made up of tiny particles called as atoms. Though we have not introduced this term right now, we'll talk about it in further lectures. But what we need to understand over here is everything which is classified or called as matter is made up of particles. Okay, I hope I made my point clear to all of you. Now let's move ahead and talk about the second physical nature of matter, which is particles of matter are small. How small, and how do we get to know whether they are small, right? So let's go back to the same example. What we have done, we have taken a beaker, then filled water inside it. Yes, then we have added some amount of salt inside this or sugar inside it, and upon giving it a stir, the salt have got dissolved. Where did the salt went? I have already shown you the zoomed image of how the particles of water and salt will look like. So the salt have occupied the intermolecular space between the water molecules and have disappeared. So obviously we can say that the matter and the particles of matter are so small that they have some space between them, which the other matter, if possible, goes and occupy the space and gets dissolved inside it. Correct? Okay, let's take an example of the same house which we have taken before. We saw that house is made up of bricks, bricks is made up of sand. Now compared to house, what can you say about the size of a sand? Well, you'll say that size of a sand is very small. And even when we go and divide sand into further and further smaller particles, as I've said, you will reach at the point which we call as atoms, which are way too small and is so small that we cannot see even with our naked eyes. Correct? So by this example, I hope the point is clear that particles of matter are small. Okay. Now moving ahead, we'll talk about some of the characteristics of particles of matter. Let's start with the first one, which says that particles of matter have space between them. Okay, particles of matter have space between them. Now, can you tell me how we can prove this? Well, again, let's take the same example of dissolving salt into water. What have we seen when we have dissolved salt into water? I'm just drawing the zoomed image for you to again have a visualization. The particles of water all around, in which the particles of salt have occupied the spaces. And how could salt occupy the space? Well, salt could only occupy the space because there was space between the particles of matter. Okay, if there would not have been any space between the particles, do you think salt would have been able to dissolve? No, right? So since the particles of matter have space between them, the other particles which can get dissolved into them comes and occupy the intermolecular spaces, and by this we can say that particles of matter have space between them. Okay, great. Now next thing is particles of matter are continuously moving. Can we say how it is possible? Well, when we see water, let's say water always moves until you keep them in a, like if you keep them in a glass, that's a different story. Okay, still even if you just pour the glass down, the water will again start moving. Let's talk about the gas particles always continue to move. Why? Because particles of matter have energy in them. What kind of energy? The energy which is responsible for the motion of a particle is called as kinetic energy. So particles of matter possesses some amount of kinetic energy, and due to the amount of kinetic energy present in them, they show motion or they continuously moves. Solid does not move because the particles of solid matter have strong force of attraction. We'll talk about this thing in further slides. And they have least amount of kinetic energy. As the state changes from solid to liquid and then to gas, the kinetic energy increases, the force of attraction between them decreases, and therefore the motion between them increases. Okay. So we can also say that particles of matter are continuously moving. And if I arrange the three states of matter in increasing order of their motion, then I can say that solid is having the least motion, then liquid, and the highest amount of motion is present in the particles of gases, right? I'm sure you guys will agree with me on this part. Okay, let's move ahead and talk about the third characteristics of particles of matter, which says that particles of matter attract each other. How will they attract each other? How do we know that? Okay, if I ask you, why does this pen holds its shape like this always? Why doesn't its shape changes? Or the book or the particles of sugar or the salt, why does they have a particular fixed shape? Well, I'm sure you will answer that because the particles of matter holding each other up very strongly due to the intermolecular force of attraction or interparticle force of attraction. So because of that, they does not let the other particle to go somewhere. They want the particle to be attached or attract with itself. And because of that, particle possesses a fixed shape. Okay. But this force of attraction also varies in different states of matter. Well, if I again arrange these, then I can say that in this case, gases have least attraction between the particles, because of which they flow, they move, they do not have fixed shape, nor they have a fixed volume. Correct? Then liquid have comparatively higher amount of interparticle force of attraction. I'm sorry for the spelling. I'll just make it right. Yes. And solids have the highest force of attraction, because of which it holds its shape and always have a definite volume. Okay. I hope this is very easy and clear. Okay. Now, moving ahead, we have some questions based on what we have learned so far. Okay. The first question is, which of the following are matter? Now, before we answer this, let's try to recall what was the definition of matter. So matter was something, or matter is anything which has mass and it occupies space. That means it has some amount of volume in it. Now let's take each of these given substances one by one and see whether they have some mass or not, or whether they occupy some amount of space or not, based on which we will classify them into matter or non-matter. Starting with book. Does book have some amount of mass? Well, yes, book has some amount of mass. Does book have some amount of volume? It does have some amount of volume. So is book a matter? Yes, book is a matter. So I'll write over here matter and substances which are not matter. Okay. So book will come in this. Let's talk about water. Do water have mass? Is there a difference between an empty glass and a glass filled with water? Yes, the glass filled with water is more heavier. So water has some amount of mass. Yes. Now, if I have a glass filled with water, can I add anything more inside it? If I add more, what will happen? The water will start pouring out. Why? Because water is occupying the space which is available inside the glass. That means it has some amount of volume in it. So is water an example of matter? Obviously it is. So water is also an example of matter. Now let's talk about the next one, which is happiness. Do happiness have a mass? Do you feel more heavier when you are happy? No. Do you feel like I'm occupying more space when I'm happy? So no. So happiness is just a feeling which does not have any mass, nor it has any amount of volume. So neither it has a mass nor it has a volume. So is happiness a matter? No, happiness is not a matter. Happiness is just a feeling. Okay, I hope I made my point clear. Next, we have a cat. So cat, obviously, when you lift a cat up, it has some amount of mass. It occupies some amount of space. So cat is also an example of matter. Balloon. So when you fill a balloon with air in it, obviously it has more mass in it than compared to the balloon which is not having any air inside it. So it has some amount of mass. When you fill air inside a balloon, balloon expands. Why does it expand? Because it is occupying more space due to the air which is present inside it, right? So it is occupying some amount of space. That means it has some amount of volume. So balloon is also an example of matter. Okay. Next we have oxygen. Now we'll take the same example. Oxygen. When I'm filling oxygen inside it, its weight is increasing and the space is also increasing. So oxygen also has mass. It also has volume. So oxygen is also a part of matter. Right? Now the last thing is order of pizza. Okay. For this thing, I want you to visualize something. What I want you to visualize is, let's say you have one pizza which is hot and one pizza which is cold. Okay. Now you tell me, if you are standing at some distance from those pizza, from which pizza will you get the smell, that is the fragrance, and from which pizza you will not get a fragrance? I'm sure you will say that the pizza which is hot will give us the fragrance, but the pizza which is cold will not have any fragrance. Why? Well, how does the fragrance depends on the temperature of pizza? It is dependent because the fragrance is coming due to the particles. Okay, due to the particles. And we have seen that particles of matter have kinetic energy in them. As temperature increases, kinetic energy increases and the particle will move further. So I can say that order of pizza is also an example of matter. Okay. So I hope you understood that only happiness among the following is not an example of matter. Other than that, everything is an example of matter. Okay. The next question, what are the characteristics of particles of matter? Give one example of each. Okay, so we have seen the characteristics of particles of matter. What are those? So we have seen the characteristics of particles of matter as first one, particles of matter have space between them, right? Particles of matter have space between them. Then we have seen particles of matter have force of attraction. And third, we have seen that particles of matter continuously moves, right? So we have seen by taking an example of dissolving salt into water, salt occupying the intermolecular space And with that, we prove that particles of matter have space between them. Then, while knowing or understanding the particles of matter have force of attraction in them, we have seen that solids occupy a fixed shape due to the strong force of attraction. Then liquid have say definite volume due to comparatively less force of attraction. And then we have seen that the particles of matter have least force of attraction in gases, because of which the particles of matter of gas moves around very fast. Then we have seen that particles of matter continuously moves. Again, we have taken the same thing, that gases have the largest amount of motion or the greatest amount of motion, then liquid, and then solids, right? So I hope this point is also clear to you. So if I have to summarize the today's concepts, whatever we have learned, we have started our concept with defining matter, correct? Then we have talked about the particles of matter, or I will say we have talked about the nature of particles of matter, right? Nature of particles of matter. And third, we have done the characteristics of particles of matter, right? So I hope all the three things which we have discussed today is clear to you, and the remaining topics we are going to cover in the further lectures. So stay tuned, and thank you so much all of you for attending this lecture. I'm sure that I'll be seeing you guys in the further lectures and with more of your friends to attend this lecture. Okay. So till then, have a nice day. Take care. Good luck to all of you.